So I set you a few questions on finding trig ratios and exact values in the previous video. What I'm going to do in this one, I'm going to take you through those questions and I'm going to show you how to work the solutions for them. So, quick refresher for you, these were the 3 questions I set. So it's all about setting up the triangles, working with them and finding out trig ratios and use some of the expansions we've covered. So here we go. So the first one was, if sine A is 3/4, find the exact value of 2a. Now, sine 2a cannot be quite simply written as 2 times 3/4. That's not the way it works. A is a different angle from 2a. So we have to figure it out from there. Now, when you've got one like this, the first thing you have to think about is, can I write this in terms of just a? I know sine of a, but not 2a. Well, remember, sine 2a is 2 sine a cos a. So I can use that to be able to expand and find this. Now, sine a equals 3/4. What that means is you could set up a right-angled triangle, because all trig relates to right-angled triangles, and call an angle in it a, and you would know that using SOHCAHTOA, opposite over hypotenuse could be given there, which means this side is 3 and this side is 4. Now, it's a right-angled triangle, so we could use Pythagoras to find this missing side. We know it would be the square root of 4 squared take away 3 squared, which in this case is the square root of 16 minus 9, so it's root 7. So now I know all 3 sides in this triangle. I need sine A and cos A in this expansion. I know what sine A is. From there I can read off cos A. I know that cos A is equal to adjacent over hypotenuse, so it's root 7/4. And from that I can just plug it together. I know then that sine 2a is equal to this expansion here with the sine A and the cos A in. So it would be 2 times the sine A, which is 3/4, times the cos A, which is the root 7/4. It's then sticking it all together. So 3 root 7 on the top. I can cancel out a common factor of 2 between here, and I'll end up with a final answer of 3 root 7/8. That there's my exact value of sine 2a. So again, as I've said, it's not quite as simple as just multiplying by 2. Don't fall into that trap. Second question was, using this diagram, find the value of sine of p plus q. Now again, p plus q is not something you can just write down. You can't just assume it's one angle. You have to use an expansion on this and get the individual parts. Well, the expansion we can use, and we have, is we know sine of p plus q. And we know that that's going to be sine p cos q plus cos p sine q. And I can use these 2 triangles, I can use these 2 triangles to get my sine p, cos p, sine q, and cos q to plug in there. From the triangles, I'm able to just write them all down. So sine p, I can write down cos p, I can write down sine q, and I can write down cos q just by looking at them. So they're all little right angle triangles, so SOHCAHTOA comes into play. So here's p, so sine p is opposite over hypotenuse, so sine p is 12/13. Cos p is adjacent over hypotenuse, so it's 5/13. Sine q, opposite over hypotenuse again, so it's 4/5. And cos q is 3/5 from that triangle. So it's then just a case of plugging it in and simplifying it. So sine p cos q is 12/13 times 3/5, plus cos p sine q is 5/13 times sine q, which is 4/5. And it's then just a case of simplifying the whole thing down. So 3 times 12 is 36, plus 5 4s, plus 20, all over 5 13s, which is 65. So that then equals 56/65. We're not able to simplify that, so it stays as that. So there you go. We now have the exact value of sine of p plus q using this and the expansion. Last question was, in the triangle PQR, find p in terms of x. So I've got a 3x and I've got an x. I need to write it in terms of those. So let's imagine this triangle here. Now we know this isn't a right angle triangle. I've not indicated, so you can't just assume something. But what we can do is put a line down there and split this into 2 separate right angle triangles. Now the whole of p, we can't assume it's the median. We can't assume it cuts halfway. So I'm going to take this bit here and label it as P1, and this bit here and label it as P2. And what I know then is P1 plus P2 equals the length of P. So if I do each of these parts on their own, I can then plug it all together. So if I look at the first little triangle, this one here, I know that cos 3x equals adjacent over hypotenuse equals P1 over Q. And the second one over here tells me that cos x, that's equal to P2 over, this time the hypotenuse for that triangle is R. Now I can rearrange both of these and say that I know P1 equals Q times cos 3x and P2 equals R times cos of x. And I then know that P is equal to the sum of these two. So it's P1 plus P2. So I know then that P equals Q cos 3x plus R cos x. So I've taken my expansion and I've written it in terms of the x's and the angles provided within the question. It's all about using these expansions. Now remember, exact values only apply in right angled triangles, so sometimes like this one, I may have to take a triangle and make it into right angles, but remember you can't make assumptions, so I can't assume this is the middle here. I have to make sure I take that into account. Hope those went well. I'll see you in class for a bit more work.